we're going to be graphing sines and cosines again today, and I want to compare graphing regular functions to graphing sines and cosines. So if I started with the parent function y equals x squared, then we can make transformations either on the y values of the graph, which will affect the up and down motion, or the x values of the graph, which will affect the left and right motion. Okay? So if I had something like 2 times x minus 3 squared minus 4, there are 3 transformations there. Anything that happens on the inside affects the x's. Anything that happens on the outside affects the y's. And we start from the inside and go out. And a lot of times it doesn't matter what order you do the transformations in, but sometimes it does. So we always start from the inside and work our way out. So what effect does x minus 3 have on the graph? It moves it right 3. And that's because anything that hits the x works backwards. It has the opposite effect from what you see. So if my original graph was this, then that x minus 3 is going to move everything to the right. So this would, oh, that should work. There we go. Oh, oops. So it's going to move it over here, right 3. Okay, what effect does the 2 have? If we times the y values by 2, then every y value becomes 2 times taller. I'm not sure if it'll let me do this or not. If I can break the aspect ratio. Nope, I can't. So the graph is now going to be taller. And sometimes people call that skinnier, and it does appear skinnier, but the motion is vertical. So we call that a vertical stretch. All right, and then what does the minus 4 do? We'll drop it down 4. Okay, so anything that happens to the x value works backwards and moves things left and right, and anything that happens outside of that works exactly the way you expect it to, and it affects the y values. Now, what if I would have put a negative in front of that 2? That would flip the graph upside down, because the negative is on the outside and that affects the y values, so every positive y value flips down and becomes a negative y value, and the negatives flip up and become positive. Okay, well, what if I had 3x squared plus 1? Well, that affects the x's. It's on the inside. And if we times all of the x values by 3, what would you expect to happen? You would think that all the x's would get 3 times longer. But the x-axis always works backwards, so multiplying by 3 actually brings it in closer to the y-axis. Does that make sense? So x over 2 squared, what effect will that have? Well, if you divided the x's by 2, you would think that they would become narrower, but the x's are backwards, so it actually makes them wider. Does that make sense? Okay. So let's do the same thing. Why didn't that work? Let's do the same thing with the sine function. So the regular sine of theta looks like this, from 1 to negative 1, and then we have pi over 2, pi, 3 pi over 2, and 2 pi. So if I wanted to do 3 sine of theta, what effect is that going to have? Well, am I affecting essentially the x-axis, which in this case is called the theta axis, or the y-axis? The y-axis. So I need to make this graph 3 times taller. That's what it would look like. Does everybody understand that? Okay. What about the sine of theta minus 1? It would just be down 1. So I take this exact same curve here, and then I just slide it down 1 unit. And whenever I do that, I like to kind of put the -1 axis out there and then put these 4 points so that I can graph it a little bit easier. And what if I did negative sine of theta? Flip it left, right, or upside down? Upside down, because the negative is on the outside, which means it affects the y-axis. So that would look like this. Okay, and those are all pretty easy. But when we move to the theta axis, things get a little bit more complicated. So the sine of 2 theta. You would expect multiplying theta by 2 to stretch the graph horizontally. But the theta axis, or the x-axis, is always backwards, so multiplying by 2 actually crunches it down, and we do the same period in half the time. So now, I used to do 1 period in 2 pi rotation, and now I'm going to work twice as fast. So it looks like that. But I need to label those points, so I'm just going to go back to 1 curve. This point is obviously theta, and this point is still pi over 2. But what is that point? Pi over 4. How did you get that? It's half as big as pi over 2. So that would be pi over 4. And what would this mark be? Well, halfway between 1/2 and 1 is 3/4. And on your assignment today, it says graph 1 period. That's all you have to do. Okay. So does everybody understand 1 period there? Okay. Let's change this. The sine of theta over 3. Well, you would think that dividing theta by 3 would bring it closer to the x-axis and make the period smaller. But the theta axis works backwards, so it actually makes it 3 times longer. So I put my 4 marks, and this point is normally 2 pi. So in this particular case, the end of the first period would be 6 pi, which means the halfway mark is going to be 3 pi, and this one is going to be 1½ pi, which we call 3 pi over 2. And then this one is going to be halfway between 3 and 6, which is 4.5. What is the decimal for 4.5? Good. You are paying attention. What is the fraction for 4.5? 9 pi over 2. Okay. So 1 and -1. So the graph looks like this. Okay. Now, the only one we haven't done, oh, wait a minute. Let me do another one. What about the sine of pi theta? Well, pi is 3.1. So multiplying by 3.1, you think, would stretch it out. But it's actually going to bring it in a little bit. And so my old period end was at 2 pi. So what is the new period end? Well, the period equation, period is equal to 2 pi divided by a, or in some cases it's alpha, where alpha is the number in front of pi. So in this case, it's 2 pi divided by pi, which is 2. So it means this number here is 2. So what's the halfway number? 1. And this one? 1/2. And this one? 3/2. Like that. Okay. What if I did the sine of 6 pi theta? Well, the end point used to be 2 pi. And the new endpoint is going to be 2 pi divided by 6 pi, which is 1/3. So this is 1/3. What is half of 1/3? 1/6. And what is half of 1/6? 1/12. And then what would that be? Well, 1/12, 2/12, which simplifies to be 1/6, 3/12, which simplifies to be 1/4. And then it would look like that. Okay. Now, the only one we haven't done is a horizontal shift. So if I said the sine of, let's do theta plus pi over 2, what's going on there? We're going to slide it to the left, essentially 90 degrees. Okay? So I'm going to take this curve here, and I'm going to pull it to the left 90 degrees. What does that look like? That is the cosine graph. So the sine of, let me do it in degrees, the sine of pi or theta plus 90 is equal to the cosine of theta. So watch this. Oh, I need to move my calculator over. If I typed in the cosine of, say, 85, I get 0.087. And I did the sine of 85 plus 90, I also get 0.87. And that is always true. The cosine of any angle is equal to the sine of the same angle plus 90. You could flip it around and say the sine of theta is always equal to the cosine of theta minus 90, which is something that we're going to use quite a bit later on. So to graph this, I'm going to do one period. One period is going to look like this. And it's still from 0 to 2 pi. And I'm pretty sure, well, I'm not sure. I'm not totally sure how the answers are written. Whether you want to start at the y-axis or start at 0. I don't know. All right, so let's do one that's kind of complicated. -3 sine of theta plus pi over 4 minus 1. So we have to start on the inside first. What is this going to look like? Well, I'm going to shift everything left pi over 4. So my normal graph has pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to bump everything to the left 1/4. So I'm going to put the 1/4 marks in here. And I'm going to take this graph and I'm going to pull it left 1/4. Oops, well, whatever. No, not whatever. So I'm going to pull it left to there. Okay, then what do I do? I will go down 1, but I need to do this -3 first. Flip it upside down and 3 times as tall. So I'm gonna go down to -3 and up to -3, and now it's upside down. So like that, and then down 1. But I need to label these critical points. What is this point right here? Well, I moved from pi over 2 to the left 1/4. So this is pi over 4. What is this point going to be? Well, it's 1/4 more than 1/2, which is 3 pi over 4. So this point is going to be 5 pi over 4, and so on. All right. Oh, and you can do the same thing with the cosine. What's that? Nice shot. So the cosine is the same idea, except the original function looks a little bit different. But all the rules are the same. All right.